Can you actually carve a logo into solid steel using nothing but electricity? Today, I'm going to find out. And this time, I'm not making just another metal experiment. I'm putting the Polymath logo directly into steel. The process starts with a simple piece of steel plate. But before anything else, the surface has to be perfectly clean. Even a small amount of grease or a fingerprint can affect the result, so I'm taking my time and degreasing the entire surface. Once the steel is clean, it's time to transfer the logo. I'm using the toner transfer method, also known as LUT. The printed design is placed onto the steel and then heated with an iron. The heat transfers the toner from the paper onto the metal surface. It looks simple, but this is one of those steps where a small mistake can ruin the entire experiment. Too little heat and the toner won't transfer properly. Too much and the details can become distorted. After heating the plate, I let it cool down and then start removing the paper. And this is where we finally see whether the transfer worked. Slowly removing the paper reveals the black Polymath logo underneath. So far, everything looks good, but the toner is only protecting the metal. Now we need to make the steel around the logo disappear, and that's where the electricity comes in. I cover the back and the sides of the plate with protective tape. The idea is simple. Wherever the metal is protected, it shouldn't be affected by the etching process. Only the exposed areas of the design should be attacked. Then I connect the electrical contacts and prepare the electrolyte. And now comes the moment I've been waiting for. The steel goes into the solution. Almost immediately, bubbles begin forming around the surface. The reaction has started. Electric current is passing through the electrolyte, and the exposed steel is gradually being removed. It doesn't look very dramatic at first, but underneath the surface, the metal is slowly changing. This is the part you normally don't get to see. The longer the process continues, the deeper the etching can become. And this is also where things can go wrong. If the protection isn't perfect, the electrolyte can reach areas that were never supposed to be etched. So I'm letting the process run and watching what happens. After the etching is finished, I pull the plate out of the solution. And honestly, it doesn't look impressive yet. The surface is dirty, the toner is still covering the design, and at first glance it looks like nothing happened. But this is the moment where the result is finally revealed. I start removing the protective tape, then I clean away the remaining toner. And slowly, the logo begins to appear. This is the part I was waiting for. The Polymath logo is no longer just printed on the steel, it's actually etched into the surface. You can see the light catching the edges of the letters, and when I turn the plate, the depth becomes much easier to see. Was it perfect? Not quite. There are a few imperfections, and some areas could definitely be cleaner and deeper. But the important thing is, the method actually worked. A simple piece of steel, a printed logo, and electricity turned the design into a permanent mark in the metal. If you want to see more experiments like this, subscribe to Polymath, and tell me in the comments what I should try to etch next. And if you enjoyed watching this experiment come together, leave a like, because this is only the beginning. The next experiment might be even more extreme.